Hey y'all, so first things first, I want to go back to what we did yesterday, and I want to go back and talk about this little connection to graphs part. So quadratic equations are characterized by their x squared. The solutions have x-intercepts. So a quadratic function could have one solution, two solutions, or no solutions. That's really talking about x-intercepts there. So if it has one solution, if this is our graph, we're going to have a graph. I'll do this in a different color so you can kind of see. It's going to look like a U, and it's just going to hit the x-axis at that one point, okay? And then if we have two solutions, then we'll have a graph that's going to go through the x-axis twice, so just like that. So then we have 1, 2 solutions. If we have no solutions, though, that just means that it's never going to cross the x-axis, which is fine. That happens. So it might look like that. All right? So, with that being said, if we solve these quadratics for when they're equal to 0, we can find the x-intercept. And one way we can do that is by completing the square. So we can really easily get these to look like those square root functions we were doing yesterday. So if I look at number 1, h of x equals x squared plus 10x minus 11. Well, I probably could factor this, but I don't want to right now. So let's try to see what we could do to make this a complete square. And so what I'm going to do is I'm going to say that b equals 10, okay? Because that's this middle number right here. So I want to find b over 2 and then square that. So that's 10 over 2, which is 5 squared, which is 25. And I basically am going to want to add 25 to both sides. But the first thing I want to do is get rid of this 11. So I'm going to add 11 to both sides. And then I'll get h of x plus 11. And then since I'm adding 25 to one side, I've got to add 25 to the other side. And let me erase some of this to give me some room. I have x squared plus 10x plus 25. Okay? And so now that I have x squared plus 10x plus 25, h of x, we're going to look when h of x is 0. So let's make this 0. And so we just have 11 plus 25. So on the left-hand side, we have 36. On the right-hand side, we have x squared plus 10x plus 25. Now, if we have x squared plus bx plus b over 2 squared, which is what we have here because our 25 was b over 2 squared, that's going to be equal to x plus b over 2 squared. So now we have x plus 5 squared. And now this looks like something we know how to solve. So I want you to pause it and try to solve this the same way we did yesterday. Okay, so I'm taking the square root of both sides. I get that x plus 5 equals positive 6, and x plus 5 equals negative 6, and then I should get that x equals 1 and x equals negative 11. Okay, so now let's look at number 2, g of x equals x squared minus 10x minus 24. I'm going to go ahead and say that this is going to be equal to 0. And I'm going to add my 24 to both sides. Okay? And so I'll have 24 equals x squared minus 10x minus 24. Oh, no, I added 24 to both sides, so I do not have minus 24 anymore. Okay, so now my b is 10 again. So I'll have b equals 10, and then b over 2 squared is 25 again. So I'm adding 25 here and here. 24 plus 25 gives me 49. This equation is going to be, oh, one thing to notice, my b here is negative 10, which is fine because this is still 25, but now we have x minus 5 squared because b over 2 is negative 5. Okay, so now we just solve it like we did yesterday. By taking the square root of both sides, we get x minus 5 equals positive 7. X minus 5 equals negative 7. Add 5 to both sides would give us 12. X equals 12. Adding 5 to both sides here give us x equals negative 2. Okay. So looking at number 3, we can do the exact same thing again. So we're going to set f of x equal to 0. So we'll say 0 equals x squared plus 4x plus 3. All right, now I want to subtract 3 from both sides. So now I get 3. Negative 3 equals x squared plus 4x. And then so my b is 4. So b over 2 squared, that's 4 over 2, which is 2 squared, is going to give me 4. So I want to add 4 to both sides. So negative 3 plus 4 gives us 1. And then x squared plus 4x plus 4 is x plus b over 2, which is 2 squared. Take the square root of both sides. I get that x plus 2 equals 1, and x plus 2 equals negative 1. Subtract 2 from both sides. And so 1 minus 2 is x equals negative 1. Negative 1 minus 2 is x equals negative 3. Okay? So now we want to look at why are we doing this. So we're doing this because we can identify the x-axis and the x-intercepts from the solution. So for number 5, I already completed the square for you. Go ahead and solve this for x, and you'll see that when you solve for x, you should get that x equals negative 3 and x equals 7. Well, let's look at that. X equals negative 3 directly corresponds to this x-intercept. This is a graph of this function. And x equals 7 directly corresponds to this x-intercept. It's because since we're setting f of x equal to 0, we're finding the x values where y equals 0. So this is finding x values where y equals 0. Okay? So again, with number 4, I already completed the square for you. So we have 9 equals x plus 1 squared. If you solve this, let's see what we get. We'll square root 9. We'll square root x plus 1 squared. So we get x plus 1 equals positive 3. X plus 1 equals negative 3. So that we should get x equals 2 and x equals negative 4. Well, if we look over at the graph, we do have an x-intercept at x equals 2. So this is going to be at 2, 0. And we have a y-intercept at x equals negative 4. So it's going to be negative 4, 0. All right, so now I want you to try number 6 on your own and find the x-intercepts for number 5.